Well, hello. Oh my goodness, 7 p.m. Pacific Standard Time. Welcome, TF.
Yeah, welcome.
So
Hello,
we're gonna,
everybody. Join us.
yeah, we got Cram Crochet here, and then Zanime is here. Welcome, Zanime.
Whoa, two places at once. That's crazy.
Whoa, that's nuts, you know. And this is how we're gonna do this. So what we are doing today, because this is a Xanaverse channel. By the way, don't forget to subscribe to Xanaverse channel. And we are going to analyze a video and talk about the science behind Superman Leap. And let's see. Okay, so this channel calls Cool Worlds, and the video we're analyzing is by this guy that goes Professor Kipping. He's a Professor Kipping explains the limits of how high an alien like Superman could jump on the Earth using what we know about exoplanets to date. So it's gonna be super nerdy one. I love it. I love it. Yes.
Yes,
Oh my
yes.
god. Is anime? Who is she? I don't know. I don't know.
It's
Who's
like a
anime?
doppelganger of another person.
Right? Like who oh who is she? I feel like there's a
Clone,
song attached to it. Yes, it's a clone. It's a
suspicious clone.
suspicious clone. Oh look, we have a little ticker too. Try to create
Whoa.
some kind of fun channel over here and talk about some science, nerdy stuff, and comic books, and quantum physics, and aliens, and bizarre episodes, right?
Definitely.
All right, let me see. Bizarre episode. Oh, who is she? Or who is she? I'm getting the stuff up here. Science. Okay, so I have not watched this video.
I have not either actually.
Okay. Yeah, so I have not watched it whatsoever. And this one is going to be pretty interesting to see, to actually like watch it and analyze it, and then we're going to pause it and talk nerdy stuff, right? Oh, boom, look at that.
All right.
Mm-mm-mm. Oh, snap. Moving some stuff around here. Look. Ooh, I like this view. What do you think?
Okay.
Yeah? Yeah?
It's a
Okay. Huh? We can
well, it's
move
a
it.
black
We
screen
can.
right now, but we'll get it going.
Yeah. Well, no, it's a black screen right now, but let's see. There you go.
All
But
right.
I'm saying like I
Columbia
like how
University even.
some actual nerdy stuff, not hypothetical.
Mm.
Okay. So, I do like the layout.
Mm-hmm.
I like the layout.
Yeah.
Yeah. Something different instead of like having everybody like to the left of something, right?
To the left, to the
Oh,
left. I think it's a
everybody
song.
goes to the left. Hmm. Dynamic camera grid. I'm playing around with a different settings right now. Okay. I like. All right, so we got a new layout. Check this out. Aha. Right? We're just gonna
Oh,
be hanging out there
okay.
in the corner. Media slot.
To the right, to the right.
To the right, to the right. To the right, to the right. Because, we're trying to do something completely different in here, right?
Yes.
And
In
yeah,
this Xanaverse,
in the Xanaverse.
anything goes
In the
within reason.
Xanaverse. within,
Within reason
within,
and logic.
within reason and logic. Okay. I like it. I like this. All right, so check this out. We're gonna do this. your custom layouts, and voila!
Boom.
You like it?
I'm first.
Yes, yes, because you're my guest. You're my first guest on this first live stream on this.
Nice.
I did a live stream on this channel before, but it was from Zanime channel and streaming it into.
Oh, okay.
And then it's so funny. Like I had somebody got confused because we were all chatting, and it was my flat Earth theory. we
Oh,
were
yeah, that was a good one.
we were all chatting on the other channel, like Zanime channel, and then somebody just jumped into the Xenoverse. They're like, "Where's everybody? I don't see. Where's everybody?"
Wow.
It was cute.
It was an alternate universe.
Uh-huh. It was alternate universe. Dun, dun, dun. All right, let's get our fair use banner up, and then let's fire this baby up, right?
Fire it up.
Fire it up, fire it up. Hold on. Let me. Oh, who is she? Oh, who is she? Okay, sorry. Not sorry. Let's fire this baby up.
Hey everyone, it's David. So Batman vs Superman has just dropped in the cinemas. I hope you're as excited as I am, and I thought it would be really fun to talk about some of the science behind Superman. So there are entire books written about the science of Superman. So what
Wait, hold on a second. You have the book
Mhm.
of Science of Superman, right?
Yes, I have that book, but I don't have the physics of superheroes.
That's cool. The physics of superheroes.
That's a
James,
good one, though.
yeah, I wanna. That'll be interesting.
I'm going to try and do is try and inform the discussion with some of the very latest results from exoplanets. And in particular, let's think about Superman's home planet and whether that can explain why it is that he can appear to fly on the Earth. So in some of the early versions of Superman, he couldn't fly yet. He could just jump really high. And scientifically,
Wait,
Mm-hmm.
why did I not know that? Why did
Because
I
you're
not
not
know?
a comic nerd.
I, well, no. I'm a comic nerd, and I'm a
Okay.
Superman fan, but I didn't know that he was just leaping. I heard about the leap,
Yeah.
but I didn't know that was at the earliest comic books. It was just like leaping. Huh.
Yeah. Well, yeah. It's kind of complicated, but yeah, he did start off not flying. Yeah.
Everything's complicated.
He'll probably explain it if we
Okay.
keep going.
that's a lot easier for us to try and explain. So I'm going to try and focus on that in this video. One way you might be able to explain this is if Superman's home planet, Krypton, had a higher surface gravity than the Earth. And in that scenario, it would not be strange to imagine that the inhabitants had evolved stronger muscles in order to cope with that higher surface gravity. So a real-world example of this is when the Apollo astronauts went to the moon, and they could jump much higher because the surface gravity on the moon is much.
Wait, some people would argue this, that there was no moon landing whatsoever.
Yeah. Right. Because it's just made of
Less than
cheese. That's why. Can't land on cheese.
I know, it's in a studio. It was filmed in a studio, okay? You know, I'm gonna be pausing throughout this whole video.
Oh God. It just got you started.
Uh-huh.
Yeah. So then the question is, how high could Krypton's surface gravity really be? Now, the reason why the moon has less surface gravity than the Earth is because its mass is less. So the easiest way to make Krypton have a higher surface gravity is to pile on more mass, make it a very massive rocky planet. But hold on there are limits. You can't just pile on more and more rock. Eventually, these rocky planets will start to accrete gaseous envelopes. In essence, they start to become gas giants. And of course, that's not a good place to live. So right now, we think that the boundary between rocky planets and gaseous planets happens at around 1.5 Earth radii, or about 2 Earth masses. That's not very much, and that's actually a really surprising result. When astronomers first got started in this game, we thought that the limit would be more like 10 times the mass of the Earth, not 2. And it's bad news for Superman because now he can only have a planet which is twice as massive as the Earth. The other freedom I
Okay. Did you understand what he was saying in there? Okay, so
Kind of.
kind of. Okay, so basically, like, he summarized it that his planet must have been like larger, right? And
Okay.
then that's why like the planet, our little rock, it's a lot smaller, so he would like leap in here, because of the density. And it's because
Okay.
it's either gaseous, like a gaseous planet, how like the rocks and everything goes straight
Right.
through the like, anyways, they float a
Mhm.
lot easier through gases than through solids, obviously.
Okay. So the
Yeah.
smaller, the more gravity, the denser the gravity. Then is that what you're saying, or am I
Yes.
okay?
I have here to try and make the surface gravity as high as possible is to change the composition of the planet itself. So the mass of the Earth's core takes up about a third of the total mass, and that's the densest part of the Earth. But let's say I made that core 100% the size of the planet. So basically, I'm just living on a planetary core, a big ball of iron. So for the same mass, two Earth masses, that iron is denser and therefore the radius is much less, and that in turn will make the surface gravity higher. Because if I'm on a smaller planet, I'm closer to the center of gravity right in the middle of that planet. So setting Krypton to be two.
Did you catch that? Like the denser the planet is, the more of
Right.
a gravity it is, right? And then
Denser.
like,
Okay.
yeah.
Yeah. All right.
Two Earth masses and a big ball of iron, that gets me up to about 2.7 times the surface gravity of the Earth. So given that the highest human beings can jump on the Earth is about 7 to 8 feet, then that means that 2.7 times by 8 gives us something like 22 feet, is the highest that we could ever imagine Superman being able to jump on the Earth. Now, you might remember in Man of Steel, it said that the Earth's atmosphere is somehow more beneficial to Superman, and he's able to be stronger as a result of that. A real example of this would be blood doping, which is essentially increasing the oxygen supply in your blood. So maybe Superman's home planet, Krypton, had less oxygen in its atmosphere than the Earth does. This actually happens in the real world. I mean, athletes really do train at high altitudes where there's less oxygen, so their body.
That's interesting.
Okay. Yeah,
Okay,
so
that's a good one.
that that actually makes sense, because the less so his planet was denser than planet Earth, right? Therefore, like he just jumps on regularly on his planet, and then when he comes over here, and for example, um, have you jumped on? Have you what is it, the jumping thing? The jumping ringy thingy. What is
Oh,
it called?
trampoline.
Yes. Oh
Okay.
my god.
Okay.
Yes.
Uh-huh.
Jumpy ringy thingy. That's gonna be our first T-shirt. So jumpy ringy thingy.
Yeah.
Trampoline. Jumpy ringy thingy. That's so funny. Okay, so trampoline. Like for example, remember when you were a kid and you were jumping on trampoline, right? And then you
Mhm.
could jump like really, really, really high. Imagine, imagine Superman's planet is the trampoline, right? Or no, not Superman's planet. The Earth is trampoline. And when you get off
Okay.
the trampoline and you try to jump, you because your body is already used to jumping so high, and then when you get off the trampoline and you try to jump, and then you can't really jump.
Hmm.
It just feels weird. Have you ever done this before?
Right. Yeah.
Yeah. So by doing that, that's why he's able to jump higher, because there's l- less density on that trampoline than
Right.
it is on the ground.
Okay.
You s- that's the because the gravity pull and everything. And this
Hmm.
actually makes sense. This right here, the oxygen training, because
Okay.
if his planet was less oxygen, um, that means that the more oxygen he gets into the blood, the better, like the healthier he is. So yeah, that actually explains a lot.
Interesting.
Body sort of gets used to that lower oxygen level. And then when they come down to sea level, they perform much better. Now, the problem with this is that, at least for human beings, that doesn't actually make us stronger or faster. All it does is increase our endurance. We can last for longer without extra oxygen. So Superman would be able to last in the fight for longer on the Earth's atmosphere, but he wouldn't necessarily be stronger. So we have to come back to this idea of making Krypton just have a really high surface gravity. Now, we ended up with 22 feet for a jump before. Now, is there some way I can increase the surface gravity even higher, beyond a factor of 2.7? So one way you might be able to do this is to take a planet like Jupiter, a big gas giant, which has an iron core, and strip away all of that outer gas. And that can happen through a process called photoevaporation, but it would be pretty extreme to strip away absolutely everything. If you did this, though, I think you could probably get the surface gravity up to about 4 times that of the Earth. So the big gain here is that you've gone beyond this 2 Earth mass limit, and now you have a solid ball of mostly iron, which is 15 Earth masses. And obviously that's going to increase the surface gravity. So a factor of 4 higher surface gravity, it helps. But can we tune the dials of physics up to the extreme and make Superman fly? Now, the core of most planetary objects is made of iron, but you can imagine replacing that with something denser, something heavier. Now, to do that, you're going to have to wander up the periodic table.
Oh, geez.
Okay. Do
You
you
pulled out the periodic table. Things are going
I
to get
love
crazy
it.
now.
I love it. Yes,
Oh,
the
gosh.
Xanaverse. This is what we do, right? Periodic table. Oh my God, my nerdiness is coming out.
Towards the heavier radioactive elements, things like uranium, plutonium. Now, I should say, physically speaking, we really don't expect to find planets made out of uranium, but it is technically, physically possible. On the flip side, for comic books, this works really well because Krypton explodes from a chain nuclear reaction. And obviously, being sat on a ball of uranium, you can imagine ways to do that. So now we have a Jupiter-like planet with a uranium core. We've stripped away all of the gas through photoevaporation, and we're left over with this ball of uranium that has a surface gravity 7.5 times that of the Earth. And that's about the best I can give you. So this means that unless Kryptonians on Krypton can jump way higher than Earthlings can on the Earth, that when Superman comes to the Earth, the highest he should be able to jump is about 60 feet. All right, don't get me wrong. If I saw someone jump over a 6-story building, I'd be pretty impressed. But that's some way off the events that we see take place in Man of Steel and Batman versus Superman. So when you go see the film, suspend your belief a little bit, have fun. But at the same time, I think it's kind of fun to imagine what a real-world Superman might be capable of. So thank you so much for watching. We should have a new video coming on Thursday by my graduate student, Alex. Make sure you...
Nice. I like it.
Okay.
Okay, so let's talk about it. Let's break it down a little bit, okay?
Yeah.
Okay, so he was talking about the surface gravity on Krypton, right? And then we related it to the jumpy round thingy.
The trampoline.
Yeah, the trampoline.
Yes. Yeah.
And so it's basically like his planet will be the ground and our planet will be trampoline, right? Because and then when you jump, like when you jump really, really high on the trampoline, then you try to jump on the ground and you just can't really jump, right? Okay, so it's just kind of like a comparison. It's the density that he was talking about because of the iron core and the gravity pull. So his planet is more dense and has more gravity pull than our planet is. It's like a rubber band, right?
Oh, okay.
Yeah.
Okay.
Yeah, so the take like 2 different rubber bands, the same size in lengthwise, but they have one is thicker and one is thinner, right? So because one is more dense, the other one is less dense. And when you pull it apart, it's going to be harder to pull the thicker one, like a rubber band, and then a thinner one, right? And then
Okay.
we'll just call that a gravity pull. Does it make sense?
Right.
Okay. Then he went on to, like basically explaining like moon surface gravity, kind of like moon surface gravity. Is a lot. Well, there's no atmosphere too, so I guess he would have compared it to just the gravity wise. Okay, so moon surface, because it has more dense, it's more density, and it's smaller, right? So that's why their
Right.
astronauts were able to jump higher, but it still has gravity.
Okay, so that's a good correlation, like comparison then.
Okay, so let's see, human performance, the oxygen, and then because his planet has less oxygen than our planet, he's trained for the less oxygen. So that way he can last. He mentioned here he can last a lot longer in the fights because he's getting a lot of oxygen into his blood.
Okay.
But from
Cool.
to be kind of a devil's advocate in this thing right here, but then he would. So if he gets a lot of oxygen in his blood, then he will get like really lightheaded, and then he won't
Yeah.
actually be able to um he won't actually
Right.
be able to last longer because he's lightheaded, right? But then also
Right.
the longer he stays on planet Earth, the the longer he stays on planet Earth, and then that means his powers will be diminishing because
Hmm.
he would be equalizing, like he would be getting
Right.
like getting actually used to the way the Earthlings are, right?
Yeah. Right. Well,
Okay.
I mean, well, also like his physical makeup is different. Um, so I believe he has like a larger heart and lungs, I believe.
Mm-hmm.
According to the comics, I guess I saw like one diagram. It's pretty explained in this the book I have, the Science of Superman. It well, not that it's actual possible, but like how it could be.
Mm-hmm.
Um, so like his physical makeup would allow for those limitations.
Oh yeah. Sorry, I turned the music on a little
Oh, that's
bit.
fine. Yeah,
All right, let's do something
yeah. I mean,
cool.
yeah. I mean, someone wrote a whole book on it, so it's like it's not just easily. I think he was just
Yeah.
kind of and then also the yellow sun, like that gives him power. Sort of photosynthesis, like
Okay.
um, so that also helps, like gives him like a second wind type thing. Um,
Hmm.
yeah, it's something that can be really explored. I mean, I think he was just touching upon like as far as just the leaping, as opposed to like the flying. So okay, so what from what I'm understanding is if you want for him to be able to fly, the gravity would have to be even less than Earth's. So it could be on another planet. He could be able to fly.
Mm-hmm. Like
Okay.
for
Okay.
example, if we went on another planet, like I don't know, let's call planet Xenoverse planet, right?
Okay.
So we went, and Xenoverse planet is smaller, it's less dense, it has less gravity, and
Hmm.
it has let's see, but it has so much oxygen. It was like an abundance of oxygen, right, than the planet Earth. So
Okay.
if we went to this planet, we'll be able to jump higher because we got used
Hmm.
to having like more dense planet and then more gravity.
Right.
Yeah.
Well, would there be more? Okay, so see, this is how much I know about science. So would it have to be more water, or would it have to be more plants to create the carbon dioxide to create the
Plants. Yeah,
oxygen?
plants.
Plants. Okay, so it'd have to be a pretty and dense, uh, like forests and plants that would give
Yeah, the
off oxygen.
jungle, like the
Okay.
jungle. Because
Okay.
how do you think? Because plants, they consume carbon dioxide and then they
Right.
release oxygen, right?
Right.
And water, well, it will have to have water, obviously, on this planet. And because that's
For the
what that
plants.
gives
Yeah.
lives. Yeah, that's what they give lives to the plants. And then also that's what creates the weather, and then this big
Hmm.
old ecological circle of life type mumbo jumbo.
Okay.
So
So just a smaller Earth would be able
yeah,
to sustain someone being able to
yeah,
fly.
yeah,
Okay.
just a little smaller Earth,
Okay.
little tiny planet Earth, like tiny one, like this one, you know.
Well, not exactly, but yeah.
It's a tiny Earth for tiny people in the chat.
So, what is the image? Are those the different types of light
Oh, the
light rays?
background, the
Yeah,
background image.
well, not that,
No,
but yeah, the background.
this one.
Yeah,
No, it's
you don't know.
just it's just it's not even magnetic field. I think
Oh,
it's
okay.
just like
That's what I
fire
was
and
thinking.
ice,
Oh,
just
okay.
like
It's just
little
there's no really
tiny.
like technical. Okay,
Yeah.
just
I
looks
do
cool.
I do have a little video of planet Earth and how beautiful it is.
Hmm.
But let's see.
Yeah, this is
Mhm.
definitely something we could explore on different
Oh
different
yeah,
planets and like the effects it would be on people, and then with like more space exploration. That's definitely a cool subject to expand on.
I like it. Okay. Uh, it's so funny. I just typed in science of
Mhm.
Superman into the YouTube, and then this live came up.
Yes,
I love it.
nice.
Algorithm, pick this up. Algorithm. Oh my
We're
god, I love this guy.
algorithm and we're algo. What is it called? Like,
This is why you
whoops. We're we're algorithmin. I don't know how you
Yeah,
say it.
wait. Algorithmin.
Algorithm. I don't
Algorithm.
know. Okay,
Alg
we're, we're getting, that's cool though.
algorithmin.
That's cool. That's gonna. It's probably gonna see because not many people like will. So, like the video we just watched. Like, yeah, it's very technical, but and like academic, but
Mm-hmm.
you have to approach it from you know a
Yeah, like
more like kind of uh,
well,
you know
a lot of people, and I completely understand that,
Mhm.
because I work in a field that I have to be translator over like a lot of scientific language,
Right.
um, because between a policymakers and a scientist, for example, they will be working on the same project, but they will be arguing constantly, saying like they're working on
Mm.
different things. But this is where like a lot of the emergency managers come in, or a lot of like people who have the scientific background and have a policy making background as well. They come
Mm.
in and then able to like translate the languages.
Right. Is
So
it more in
that's
layman's term or just in a more um uh like oh, what's it called? Not technical term, but like more of a like able to make things happen. I guess I don't know if that's layman's term or not, but
yeah. Yep.
functional. I was gonna say functional. It's more in functional terms that people can understand. Then
Yes. Functional
okay.
terms. Okay, so I found this video. I should have looked it up a while back. I love this guy. His channel is because science. He
Okay.
explains science fantastically. Hold on, let me put
All
it in
right.
a chat. Let me put his channel in chat, and I'll quote him over there under
Okay.
the banner later, because I love this guy. Like I've been following him for years. So, and he actually has a video say why you don't want the power of flight, and he talks about the Superman.
Mhm.
So let's see. We are going to do this. Where's the screen sharing? What's going on in here? All right, hold on. I was playing around with layouts again. Cuz no. Okay. Now I was playing around with layouts cuz we want to be different on here than just like sometimes people just kind of I would say, wait, hold on a second. No. You keep talking. I'm working.
Oh,
I'm working on here.
I don't know if you got my message. I just had to be
Oh
right
no.
back, but I'm back.
Oh, okay. Nice. Okay, so no, I was just working around with some things, and then for
Oh,
some, you see this,
yeah, that's a nice layout.
right? I like it. I like this
You get to
layout.
see the background. You get to see all
Yeah,
the elements.
but
Well, that one's
see,
good too.
you like this one?
Oh, sure.
But this is the typical one, you know.
The
Everybody
generic one.
always to the
Put
left.
it back on.
Yeah,
Put us back on top. There you go, and then play it.
yeah. I just need to add an item to it.
Oh,
Hold on. It's like a little things.
even in Xanaverse, we have technical difficulties.
No, it's not technical difficulties. This is just me playing around for my first live stream.
Okay, technical experiments.
Yeah, there
Not
you
difficult.
go. There you go.
Technical experiments.
Technical experiments, because we want to eventually customize this thing, right? All right, so technical experiments. Cool. I like it. I like it a lot. Yup. This is awesome. Oh, I'm making 4 slots just in case we get other people. Ooh, you
Okay.
wanna... Should I drop a link? Yeah, I should drop to see if anybody wants to come in. Right? Yeah.
Sure.
Come on the panel to talk about the science behind the Superman flights. All right.
You shared the link. Yeah. I'm sure
yeah.
people will come in once they understand.
Right. Once they understand.
No, I mean, then once he understands an open panel, I meant.
Oh yeah.
I still don't understand. So what do I know?
You totally understand. You know, just think of it as a
No, I
very... Yeah, see, you get it. You understand. Okay. Yes, I like this layout. Save a new layout.
Like you're flying up in the air. See, your avatar's already a circle, like a planet. So look like the Xana planet.
Xana planet.
Floating in space with Hazy.
A Xana planet. There it
Mine
is.
looks more
Look.
like I don't know, spaceship or space junk.
Yeah, I like it. Space junk. Xana planet. This is a fun hangout spot. Okay, so I got the video.
Okay.
Hmm?
We're covered up, but that's okay.
Oh yeah, we are a little cover up. Okay, hold on. Let me see if I can edit this. Yeah.
You realize it says like and Sue on your left side now.
Wait, what? Hit the... Wait, where?
It's covering up the subscribe and it says like and Sue.
That's hilarious. Alright. Like, let's see. Update layout. How about this?
Okay.
You
Fire
can
it up.
see the video, so it's not like full screen, but
Your
you can
fair
still...
use is ginormous.
I know.
Why it's so big? Did you make it that large?
Yeah, I wanted to make that large.
Okay.
Yeah, I wanted to make that large because I wanted to make sure it's fair use so I don't get copyrighted. Come on, man.
Right. Well, you could use a different, so it's not like blocking off. Just like the indication of color, like that little strip of color.
Yeah.
That might help. So
All right. Fine. We'll just do this. See? Making me edit some stuff.
or you could make a ticker. What could you just do a ticker of fair use? Like
Yes. I can. Like this.
Okay.
Look. Fair use.
fair use.
You see it?
Barely.
It's coming. It's coming. It's coming.
It's in there though. That's all that counts, right?
Yeah. Hold on a second. It's coming.
You
It's
put
coming.
it okay, just put it at the front and at the end, and then you're good.
Yeah, there you go. Fair use.
Fair use. It's there. It's there.
Yeah, it's there. And then we'll do it. Fair use. There you go. Boom.
I'm ready to watch why you don't.
Want the power of flight.
Okay.
All right. Let's pause the musica. I'm gonna pause the musica, and then we'll start this show.
This is why you don't want to fly like a superhero.
If I had to guess, the power of flight is the most desired superpower. And don't get me wrong, if you could fly around like Superman all day, it would be pretty dang awesome. You could make your daily commute an adventure. You could see the whole world from a new perspective. And airlines? Oh, who needs them, buddy? But this is what pop culture says is possible. If we think about the potential drawbacks of a power like flight scientifically, I don't know if you'd even want it.
Yeah, this guy's
I
awesome.
descend!
Okay.
First, I want to be very clear about what I mean when I say you don't want to fly, because the power of flight has many more interpretations than a power like super strength. The kind of flight that we will be interpreting is, I think, the most common version of it. An epic ability that allows someone like Superman or Neo to move above the ground at high velocity and high altitude. And like Superman, we are going to say for this version of flight that you can just go. If we have to start evaluating thrust and fuel requirements, this analysis isn't going to really get off the ground. I will argue that though this version of flight sounds awesome, it would be more hassle than it's worth. So much so that traditional air travel just might be preferable. $30 bag fee now? That is bold. Let's consider flying at high altitude first, because if you could fly, you probably will not be going very high. The Earth's atmosphere does not have a definite boundary with space, but we consider it to extend all the way from the surface out to around 100 kilometers, what we call the Kármán line. And as you move further,
Hold on a second. What we call the Kármán line.
Okay. That's
Huh?
what he calls it. That's
Yeah.
what they call it.
Right?
away from the surface, the air in the atmosphere thins way out. The Earth's atmosphere is not evenly distributed. A full 80% of the Earth's atmosphere is crammed into just the first 10 kilometers above the surface. This leads to a drastic difference in air density, which leads to a drastic difference in oxygen availability. Fly up above the clouds and oxygen availability will be your first altitude limiter. If you go up around 19 kilometers above the Earth's surface around...
Wait, what's going on?
I'm lost on the kilometers.
So 19 kilometers will be 11 miles, something like
Oh, okay.
like
That makes more
12 miles. So
Okay.
he was talking about like the oxygen levels, right? So for
Right.
example, let's see. Have you heard of a halo jump? Halo jump is a high altitude military parachuting jump. It's
No.
like
No, I have not.
Okay, so halo jumps is you go up like really, really, really high into the atmosphere, and you have to have a mask on you because
Oh, wow.
the higher you go, the less oxygen it is, the less density of
Mhm.
oxygen, right?
Mm,
On the
mhm.
planet. So that's why like the halo jumps, they'll go like way I think they'll go up to 30,000 feet or something like that. Hold on, let me look it up. Okay, so
Okay.
yeah,
How
so
many does it?
it's 35,000 feet. So it's the altitude between 15,000 and 35,000 feet.
Okay.
It's really high. It's like really, really high. And halo means like high altitude, low opening. So
Oh, okay. It's abbreviated. Okay.
yeah, it's abbreviated. And they have to have a mask because there's no oxygen up there, right? And you know how people in the jets, they also have a mask on,
Yeah.
right? Because once they get like up higher, there's a lot harder to breathe. It's just kind of like climbing a mountain,
Right.
right? The higher you go, the less oxygen it is, and that's why you cannot breathe. So I would say it would be the it would be like halo jump will be like somewhere here. You
Wow.
see? Yeah.
Even
So
higher. Okay. All right.
yeah. So you go like somewhere here to.
How do they get that up there?
Actually, hold on a second.
Like a freaking rocket?
90 kilometers, 2 feet. Oh, actually, no. Never mind. Never mind. Sorry. Not up there. Sorry.
Oh.
It's gonna be. It's a 62,000 feet. So halo jump will be somewhere right
Oh, lower.
here.
Okay.
Yeah. So
Oh,
somewhere
okay.
like right here.
Hmm.
Or no, like yeah, between 4 and 10, somewhere
Between.
like here.
Okay.
Yep. So not here. And
Okay.
for example, like when Jeff Bezos went to space, right?
Right.
And he said like, "Oh, we sent a rocket to space." And technically, he didn't go into space. He just went into upper atmosphere. Um,
Right.
so to be able to reach space, imagine the 12-inch ruler, right?
Mhm.
And you have all of these notches in there. The very, very first notch, like on the 12-inch, like the very first centimeter notch, and this is how far Bezos went. And to be able to reach space, you have to reach at the end of this ruler.
Hmm.
You see?
Okay.
So, like, you actually have to break the stratosphere and then go further. So, what he's talking in here is the higher you go, the less you can breathe. So, technically, you couldn't really jump with
Right.
this. All right, let's continue.
Mhm.
Around 12 miles, you would have to wear a pressure suit just to keep your body from dying, like Felix Baumgartner wore when he dropped from space. Go up around 12 kilometers, and you would need to breathe pressurized oxygen like scuba divers do. Up around 4 kilometers, you would need oxygen still, and it would only be once you got below this 4-kilometer line, about 2.5 miles, that you would be able to safely breathe the air around you. So you can forget if you had the power of flight, flying over Mount Everest just for fun.
Paging Kyle Hill in the terminal.
Gate 42.
Do not let any strangers pack your luggage without.
These altitude-based oxygen limits aren't just suggestions either. Fly too high and you can pass out almost immediately. Do you know why airlines tell you to put on your own mask before assisting others in the event of a rapid decompression? It's because when your body is exposed to ultra-thin air, you may have only a few moments of useful consciousness. For example, at a common cruising altitude of, say, 40,000 feet, you can become dangerously oxygen deprived in just 5 seconds, and you pass out shortly thereafter. And I'll tell you, crashing into the ground from this height would end your super life super quick. I mean,
That's crazy. 5 seconds.
Wow.
That's why you gotta put on your oxygen mask before you put on somebody else's.
This is your captain speaking. We're probably going to be fine. I wouldn't worry about it, but I will be honest with you.
Well, you
Nothing
can
in
be
here
alive when you
has any
crash.
numbers on it, so kind of just winging it.
the
That's
other
almost
altitude
morbid.
limiter
Huh?
That's almost like, okay, so you can be conscious while you're like hitting the ground, in other words.
Yeah, pretty much.
All right.
Well,
All right.
also if you change the altitudes like really, really fast, your body's actually not gonna be able to adjust right away. So, for example,
Oh.
if you go skydiving, you cannot
Mhm.
go scuba diving within the same day
Oh,
because
interesting.
of your blood is just gonna like your vessels are just gonna explode.
Oh, why would you do
So
both in the same day to begin with? But
I don't know,
you'd have to be
adrenaline
like a
junkies.
daredevil for that.
Yeah, well, it's like if you go up in a plane, you cannot go into the submarine the same day because of the different
Oh,
pressurized, right? Then your body just won't
interesting.
be able to handle it. And then the lower, like the closer to the core you go, like for example, diving like on a submarine and stuff, right? That's why like a lot of people train for the oxygen and for like the elevations and stuff
Hmm.
because you can't do a drastic change. We're not superhumans. We still have to acclimatize
Right.
and adjust. And continue on.
For humans, superflight also has to do with how thick the atmosphere is and its temperature. The amount of heat energy in a system is directly related to the amount of mass in that system. And so, as we said, you go higher up in the atmosphere and the mass per unit volume goes way down. And so the heat energy is going to go down. So in general, the higher up in the atmosphere that you go, the way colder it gets. This increase here is just because of the ozone layer, and it, helps life on Earth be. Now, where
That we're trying to destroy.
do you think your comfortable temperature zone would be based on this chart? Because before you even get 10 kilometers up, it's negative 50 degrees Celsius outside, and that would freeze your pee. If you didn't want to go any higher than 4 kilometers in the atmosphere because of oxygen availability, you wouldn't want to go any higher than 3 kilometers because of temperature. Any higher than that, and you would literally start freezing.
All right, so you can't fly as high as you thought. So what? You'll just do all of your superheroing, not enough oxygen, getting woozy. So you can't fly as high as you thought. So what, right? You'll just do all of your superheroing. It is freezing up here. Just 1 second. So you can't fly as high as you thought. So what? You'll just do all your superheroing closer to the ground at top speed, right? Well, unfortunately, you'd be velocity limited too.
Another problem with flight, specifically flying really fast, is again, temperature. Right now, your body is most likely in contact with some kind of air, I hope. And when those air particles hit your body, if they are colder or have less energy than your skin, when they hit your skin and bounce off, they will gain a little bit of energy and your skin will lose a little bit of energy. This effectively lowers your skin temperature in a process called convective cooling. This happens even when you're standing still, but once you start moving through the air, you're giving your body more opportunities to have these little collisions and these little energy exchanges. So the faster you go through the air, the more your rate of convective cooling increases, and that's why the wind starts to feel colder.
Oh, also, did you understand this? So the faster you move, the colder
Right.
your body gets, right? Because of the the
In
movement
the
and the
air.
wind. Yeah, in the air.
In the air.
So,
Yeah.
and also, there's nothing that moves faster than speed of light. So technically, you can't even fly that fast,
Okay.
right? You can just like do slower. Anyways, I went on into
Okay.
different realm of a Xenoverse.
What I'm getting at is if you fly through the air at high velocity like Superman, you can experience significant wind chill, as this chart shows. And depending on the ambient temperature, even if you go as slow as 100 kilometers or 60 miles per hour through that air, you can get frostbite on your skin from wind chill in as little as 2 minutes. Stop it. If heat loss doesn't slow you way down, something more immediate will: a mid-air collision. Bird strike is not the name of a cool avian superhero. It is instead the term for when a plane unfortunately hits a bird mid-flight. There are an estimated 13,000 bird strikes in the US alone each year. And it can be very, very serious because although birds are very small, relatively speaking, compared to airplanes, their change in momentum and therefore their force on impact can be huge. When a plane hits a bird mid-flight, the bird will go from whatever small velocity it was flapping along at to the plane's velocity, which is enormous in a very, very short amount of time. And from smart boy Isaac Newton's equations, we know that even though the bird weighs hundreds of thousands of times less than the plane, this force is still going to be tremendous. What? Oh, Zone 2 is boarding? Yeah, no problem. Even if we assume a very small bird just
this this guy's funny. So, bird flight. Splat.
1 pound and 1 foot long, and an average cruising velocity for our plane of 550 miles per hour. The average force on the plane from this tiny bird could be as high as 90,000 newtons, 20,000 pounds of force. From this simple calculation, I think you can see how bird strikes can and do damage and disable aircraft. And aircraft are made out of metal and meant to fly. So now imagine what a single unlucky bird strike would do to you or your face cone. Yeah.
Or
Face
a
cone.
bug. Face cone.
Face cone. Never
I
face
love it.
cone.
Or like a bug, you know. So
Oh yeah, that's
instead
true.
of a bird, if you like run into a bug, what
Oh
is that gonna
man.
do to you?
Yeah.
Oh, okay. So if
Take
when
out your eye.
right? When Superman flies, does he eat bugs all the time?
Apparently.
Is that his source of protein?
Yeah.
Like how
I don't know if
does
he
he
I don't know if
stay
he
so
flies with his
clean?
mouth open though. I've never seen him. Maybe he does. I don't know.
How does he stay so clean?
That would be funny though. Birds or bugs on his it's like a bug shield on his face.
Uh-huh. Bug shield. Like one of those COVID shields.
Yeah.
So to
Face
minimize the
cone.
chances of being fatally struck, you would want to slow way down again, way below the speed at which airplanes fly at. You could take your chances with a bird strike, but if it happens, they won't make a movie about your life starring Tom Hanks. My point is that if you could fly like superheroes do and didn't have any additional powers to protect you, bird! Woo! If you didn't have any additional powers to protect you, your best bet would be to fly low and slow, and even then, there'd be more restrictions on your flying than you may think. Let's just think of everything we would actually need in order to fly in a more realistic and heroic way given everything that we've gone through so far. Well, you're probably going to get too cold and you might subject yourself to pressures you don't want, so how about a flight suit? We need one of those. And oxygen. We're definitely going to need a tank of oxygen depending on what we're doing. And even though we're going to be going relatively slowly, we still want head and eye protection, so let's bring a helmet and goggles. Oh,
I like
and
that
just one more
helmet.
thing. Let's make a phone call to the FAA and government telling them that a human has superpowers for real and is going to be flying over populated areas for extended periods of time whenever they want, and also doesn't want to be immediately captured and experimented on by scientists.
Okay.
Well, that means like if if a human can actually
Yeah.
fly for real, and then they're gonna be flying above above
Right.
the cities and everything, and we still have flight zones. We have like
Yeah.
flight
Good point.
zones, no flight zones. So that means that that human has to be
Mhm.
registered as a flying craft,
Yeah.
and he has to follow the FAA rules.
Yeah. Interesting.
Yeah. Oh, you know who it is. What? You're headed here right now to take me to an unlisted government black site? For how long? Indefinitely. Oh.
Yeah. Hang up.
Even if we somehow lived in a world where everyone would just be suddenly cool with an unidentified human-shaped flying object all the time, there would still be rules and regulations on you. Not only would you have to fly low and slow, it's the 21st century. You have to fly with other people in mind. Before taking off, just like an actual pilot, you would want to check weather reports, rules and regulations in your area, and airspace maps, and fly according to those. For example, though most of the air you would be flying through would be unrestricted, if you live near a large city, you might be near a large airport, which restricts and monitors its airspace for miles around in every direction. You could just wing it and take your chances with running into a thunderstorm or running headfirst into a missile from an
Or running into a
Missile.
plane.
Unless it just or head first into a missile.
Right.
It just happened to be from an F-16.
F-16, but I would not recommend it. Look, I will concede
not
that
recommend
some kind of flight power that had you just floating above the trees at the speed of a car over to your friend's place would be awesome. But then again, that's not really the version of super flight that we see in pop culture, is it?
So if you don't want to fly, as I argue, what would you want if you still wanted to fly? Well, if you wanted to fly more realistically without all the hassle, we are now more or less describing Iron Man. With his suit, he has temperature and impact protection, so he's not velocity limited. And with his navigation and sensors and contacts with the government, he's not altitude limited. But at this point, you've created a suit that does more than the power of flight alone does. So you might as well just be Iron Man and forget the power of flight altogether.
Will Kyle Hill please report to baggage claim? You left a barrel of hair ties in the terminal.
Come on.
So why don't you want to fly like a superhero? Well, if the power of flight is all you have and not invulnerability or super durability or...
Well, what's up?
Oh, he's the hair ties, and then his hair's tied back. So
Right.
got him.
what have you, flight wouldn't be quite so super. Because of oxygen and temperature limitations, you'd want to fly low and slow, and because of civilization, you'd want to fly more safely than you probably thought you could. Of course, you can fly warm, breathing nice oxygen-filled air at hundreds of miles per hour in relative safety, but we're just describing commercial air travel now. Unless you innovated like Iron Man, we humans have figured out how to fly pretty dang well, no powers required. Because science. First class, baby, coach.
Okay. Well, he's also looking at it as like if you were more human, but if you're Superman, you've got all those other powers and vulnerability, and it's a superhero, it's fictional, but
Yeah,
there's
of course.
more to it. Like he's got the things that in other words, what he's saying would limit us. It wouldn't limit him because he's got these other things to compensate for that. That's, you got to look at it from that perspective. So it's like in a fictional sense, he's got ways around that if you want to look at it logically. But if it's just a person, yeah, it would make more sense to be like Iron Man. But as a superhero, it's
That's why
other
we have
powers.
That's why we have Iron Man and Superman,
Right.
and that's why they're fictional characters.
Well, you can't create an Iron Man suit. So.
Right.
Oh,
I don't have that money to create an Iron Man suit.
yeah, it's all fictional and exaggeration, anyways. So,
Oh yeah, for sure.
but
And then, so there's like another thing. For example, like if you go in if you're going from a higher atmosphere to a lower atmosphere, there's terminal velocity as well, and terminal velocity has its limit. It's about like 150 miles per hour. So you cannot go, like, basically the object cannot fall faster than 150 miles per hour.
okay.
And you get to learn that skydiving too, which is pretty
Oh,
neat.
okay. Interesting.
Yeah, so it doesn't matter of your weight. It doesn't matter like of anything.
Yeah.
It's 150 miles per hour.
Yeah. Well, I've never been skydiving, so I don't know. So how does that feel being up there? Like, do you feel like being pulled down, or does it feel like gradual? Like,
So the initial jump, like from the airplane into the air, you feel it. Like you feel the initial because you jump in from a moving plane, right? And then you feel that thrust when you just get into
okay.
into the air. But when you're falling, it does not feel
Yeah.
like you're falling whatsoever. Like your body doesn't
Oh, really?
feel, yeah, it doesn't have that like, oh my God, I'm falling, because your body adjusted to because there's nothing else for you
Oh.
to compare with the movement, right?
Oh,
Like
interesting.
there's
Okay.
nothing else for you, like for your body to compare with the velocity, and you just fall, and it doesn't you don't feel the gravity at all. But
Oh, wow.
you see the gravity, you see
Oh, yeah.
it.
You see
As
things
in,
getting closer. Yeah.
yeah, exactly. And then you have to pull the parachute like at at least like 4,000, like before the 4,000 feet, or 2,000
Okay.
feet will be like your last resort to even save
Oh,
yourself.
wow.
Yeah.
So anything less than that, you're gonna smack.
Oh yeah. Oh yeah. Yeah.
Wow.
Yep.
Does it increase after 2000? Like, do you go? I know you say you don't feel it, but even though you don't feel it, does it go after 2,000 feet? Will you fall faster? or is it really?
No, it's 150 miles per hour. You fall 150. And imagine
Okay.
your body slamming into something at 150 miles per hour.
Right.
So it doesn't
Okay.
decrease. It doesn't.
So what I was asking is that when you're you jump off the plane, you're going at 150 miles hour, regardless whether
Mhm.
you're 4,000 or 2,000.
Yep.
There's no
Or
increase in speed.
14,000 or 35,000.
All right.
So, and that's the terminal velocity. It's a steady speed that are achieved by like any falling objects through the they fall through gas or like liquid or stuff like that. So it's yeah.
So if you don't pull your, I know you're gonna hit the ground and die, obviously, but like you wouldn't feel any increase in speed.
No,
Interesting.
no, you wouldn't
Okay.
because it's it's like the law, like we have the speed of light is the fastest traveling, right? So there's no, but if you actually get a little bit more into quantum physics, because we're like on the verge of having more like quantum physics more available to study, and there's a
Okay.
new developments constantly happening. So because and we can get into that in completely different lives. Like I can actually explain it, quantum physics, dumb it down.
That might be above my
No. I think I
my
can.
head
I
to
can.
get somebody else
No.
more
So
mathematically inclined than me to do that.
okay. Think of Inception, right?
Okay.
Think of the movie Inception, and what I can do, I can get into live to talk about the relativity of Inception to quantum physics, and then how to
That'd be cool.
explain the quantum physics with the different movies.
That'd be nice. Yeah, that sounds
Yeah,
really cool. Interesting. Should definitely do that.
yeah,
That would be very, very
could
interesting.
be fun. Could be fun. But yeah, so I think this is good. I like
Yeah,
it.
fun.
What do you think?
It's definitely a good jumping
It's a
point.
good start.
It'd be
It's a
nice
good
to explore, like
start.
you said, other movies or maybe other superhero type, you know,
Mm-hmm.
powers that may,
Yeah.
be
Why don't
possible, but
we
not to the
do?
limit of, imagination. But
Why don't we do Watchmen next?
that sounds cool. Yeah, there's a lot of different.
Mm.
Yeah, they all have like varied powers. So yeah,
Mm-hmm. Okay.
sounds
Awesome.
good.
Well, I'm glad that we got a couple messages. This is a good start for a tiny, tiny, tiny channel. It's a great start, actually. To get.
Universe started off as a microcosm, and now it's going to grow into a universe,
Well,
right?
Xanaverse started with a flat Earth theory, and then
We started with a
debunking it.
pancake or a tortilla, and now we're going to be a giant. I don't know,
Right.
planet tortilla.
The giant planet tortilla. Oh my god, the flat earthers. We can do it again, because I actually kind of like that live. I can bring out my slides again.
Okay,
Give
as
the
long as you don't show the periodic table again.
Why not?
That was in the video.
I know, but
I
why
don't know. The
not?
periodic table scares me.
Is it intimidating?
No,
What is
no,
it
not really.
intimidating?
Oh, ah! How dare you! I'm gonna have
Okay.
multicolored nightmares now. I'm gonna have night terrors of periodic table.
Night terrors. That's funny. So fun fact on a closing point. So uranium, right? Raw form of uranium is non-radioactive. It's only
Okay.
radioactive if you start bombarding it with chemicals, right? Or any kind of like chemical elements, like natural chemical elements, you know how like erosion happens,
Right.
style. And so once it gets bombarded with different chemicals, it starts the activity process, and the atoms
Mm.
are trying to balance themselves out. You know, the negative and positive. So because they're constantly activated, and so because everything on planet Earth has to have a balance, right? Like a negative and a positive. So it's about
Mhm.
creates this balance, and also creates like density. And for example, like the table, because it's very dense, there's no activity, there's no atomic activity in there, right? But because it's already the way it is, it's balanced. So that's what uranium is trying to do, balance itself out. Once it goes through
Okay.
all of the different processes, right? All of this through different checks and balances and everything else, through like this whole crazy, I don't know, like millennia, whatever. The final byproduct of uranium is lead.
Okay.
Lead is the most dense metal, um, and that's why when you go to get your X-rays,
Mhm.
because lead is so well balanced, and when you
Mhm.
get X-rays, that's why you wear lead vest, because the radiation, it cannot penetrate lead, right? Because what radiation does, it activates like all these atoms within radiation, it activates like other atoms, and then they try to become balanced, right? But since lead is so just dead, it's just like a dead metal, like there's no activity whatsoever, it cannot, there's nothing to balance it out.
Hmm.
So yeah,
Interesting. Okay.
lead used to be uranium.
Oh, I didn't know that. So,
Hmm.
I mean, so the lead in pencils that they used to use back in the day was uranium?
Yeah,
Oh,
did you
God.
eat those?
No, I never ate them, but
But all right, I think this is a great close out thing, and whoever
okay.
stuck
That was a
around,
great, interesting life, and I hope someone else got some fun out of it and knowledge.
yeah.
Knowledge
And
is fun.
then if you can stick around here, we chit chat afterwards. And
Hmm?
all right, so let's see. We need to come up with something for Xanaverse.
Yeah, your tagline
Yeah, I don't
next time.
know. Xanaverse out. Little thinky dingy. Boom.